Okay, so the question was what to do when there isn't a number here, and there is a number there. It's that invisible one that is the bane of everyone's existence in algebra. So it's going to work exactly the same, but it's a one there. We would do the exact same thing if we had like a six there. So we would multiply it by the conjugate. So since this is 5 plus 1i, we're going to multiply by 5 minus essentially 1i. Oops, did not write that very well. 1i. And we don't need that one there. I'm just doing this for emphasis so you kind of see what happens with it. So up top, we're going to have 5 times 5 is 25. And 5 times negative 1 makes negative 5 with that I along for the ride. And remember, these are complex conjugates, so when we multiply a plus bi times a minus bi, what we get is a squared plus b squared. So this is where that little invisible one there messes everyone up. A squared, a is 5, and the b is the invisible one, so it's just plus 1 squared. And if you do out all these steps, which I'll do here in just a second, we're going to get to that exact same spot. We just got there a lot easier doing this. And so that would be 25 and 1 should be 26. So there's our answer. And then just to show that this does work out, 5 times 5 would be 25. On the outside, we get a minus 5i. On the inside, we get a plus 5i, so those always cancel. That's where there's no cross term in there. And then here we get minus 1i squared, because 1 times 1 is 1, I times I is I squared. Those cancel, so then we're at 25. Remember that I squared, that's negative 1. So this is basically, well, it's minus 1 times minus 1. And then there we are at 25 plus 1. So the idea is to skip all this mess in between and use that shortcut. But yeah, when there's no coefficient on the I, it's our invisible 1, the same way that if there's just an x sitting there, that's really 1x to the first. So there's always those invisible ones. Hopefully that helps.